Hello, this is our preview video on functions. And we're going to look at what makes a function and then why something is not a function. So the first thing that we're going to look at is sets of tables. And the one on the left is a function and the one on the right is labeled as not a function. And what we're going to focus on are the x values, which is always on the left side, the first set of numbers on the table. Remember, these are our domains, so I'm going to highlight them on the first table in yellow, and I'm going to highlight them on the second table in yellow as well. So as far as a function goes, what controls a function is the domain or the x values. And I know on the second table it doesn't say x and y, it says a and b, but that is literally the same thing as x and y. They can use any letters that they want. The x is the first letter, it's the domain, it's the independent, it's what controls it. And if we look at what's happening on the two tables, they both look exactly the same pretty much on the x, except for the second table has a repeating x value. It has two 2's in the x column, and that's the important factor. So it appears to me that what makes something a function is that we have no repeats in x values. And remember, x values are also called the domain. Whereas if they do repeat, then it's not a function. Let's see if that holds true for our next set. Our next set is a set of ordered pairs. And once again, if we sort of remember the way these work, it's x first, y second as we go across the screen. So I'm just going to label these on each set. And once again, the thing that controls whether it's a function or not are the x values. So I'm going to highlight each x value. And I'm going to look at if there's any repeats. So on the first set, I have a -2, a -1, a 0, and a +1. Okay, on the second set, I have a -6, I have a -6, a -5, and a -5. And we can see I've got repeats because the -6 repeats in the x's, and so does the -5. So once again, in order for it to be a function, we can have no repeats in the x value, which again we refer to as the domain. If it does repeat in the x value, then it is not a function. And notice I'm not looking at the y values at all. The y values do not matter. What controls functions versus non-functions are the x values. And let's look at the last one. Remember, we can graph sets of ordered pairs and we can graph coordinates on a table. So if we were to look at a graph and we would try to decide, well, do we have repeats in x? Well, let's just highlight our x-axis on each one. If we have a repeat in the x, and that means we should have more than one point showing on the x-axis. So if I create what's called a vertical line, I'm going to do that with the highlighter. I'm going to come across this first one. You'll notice I have 1 point on the -4 for the x, and then I've got 1 point on the -1. This one would be on the 0. Remember, we're looking at x values. 1 point on the +1, 1 point on the 3, and 1 point on the 5. So no repeats. However, if I come over to the second one, I've got 2 points lining up on the -2 for the x-axis. So that means that the 2 is repeating. And in fact, if I were to write down the coordinates, the bottom one would be at -2, +1, and the top one would be at -2, +3. So you can see it when you write the coordinates that the x value definitely repeats. If you're just looking for at the graph, what you're looking to see is, do the dots stack one on top of the other? If they stack one on top of the other, they're on the same vertical line, then they've repeated the x value, and then that makes it not a function. So once again, no repeats in x, And the way that that might look on a graph, if you're looking for the repeats in the x values, you're looking for no vertical stacking. And some people say that it passes the vertical line test. And by that we mean when I hold that blue vertical line across the graph, there was only one point at a time, one dot that fell on that blue vertical highlighted line. Whereas the one that was the non-function, two of them were on there, so it failed the vertical line test. And once again, it doesn't matter about the y, and the y on this one would be the horizontal lines. I could actually put a dot here on this first one, and notice now I have two dots lined up across from each other this direction on the 5, but that doesn't matter because that's the y-axis. All we care about is the x-axis and the fact that there's still just one point on my blue highlighted vertical line, so none of the x values repeat.